ArrayLists. An ArrayList object is like a normal array, but on steroids. It overcomes some of the shortfalls of arrays, such as having the predetermined its size. It adds several useful functions to make its data easy to manage, and it is used by many classes in the Android API. The last point means that we need to use ArrayList if we want to use certain parts of the Android API. So let's declare an ArrayList here. For example, val my list here, and ArrayList. Oops, what happened? Okay. ArrayList here, and this ArrayList is gonna be integer type, for example. Integer type. So let me check, is this recording, because my application just crashed. Yes, it is recording. So now we need to initialize my list after declaring that we can initialize the same line, but for showing you, I will initialize our array list of in different line. So my list here assigned to array list here, and we called constructor here. This code we declared and initialize a new array list object called my list here. So now we can also do this in a single step, for example, like this. So far this is not particularly interesting, so let's take a look at what can actually do with array list. So let's use a string ArrayList object at this time. So for example, let's delete that and create a new string ArrayList. Val my list here, and array here, and string here. Actually, not array, actually ArrayList here. ArrayList here. And val my list, ArrayList string here, and we need to call constructors here. So now let's add a new string to my list in the next available location. For example, my list.add here, my list.add, for example, Donald Jack here, and let's add another my list.add here, Rasmus Lerdorf here. Let's add another, and my list.add. But in this line of code, we will choose where to add an entry. So we will choose one, and we will write our, for example, Richard Stallman. As you can see, we added index one, it's Richard Stallman. So is there anything in our array list? So if our my list that is empty is true, then nothing here, and else do something here. For example, we can use my list is empty. So this checks is our list is empty. So if, for now our list is not empty, and the else block will execute here. So we can determine how many items in our array list here as well, like we did in previous lectures, by using, for example, val num items here assigned to my list that my list size here, as you can see here. So where so for example, val position, for example, if we want to learn where did I put, for example, Richard Stallman. So then we will need to use my list dot index of Richard Stallman here. So this code, we saw that we can use some useful function of the ArrayList class on our ArrayList objects. These functions are mylist that are, for example, we can add an entry at a specific location by using this function. We can check whether the ArrayList instance is empty or not. We can see how big ArrayList instance is, and we can get the current position of any given time. For example, my list at index of, in this case, our position value, position equals 1, because we added Richard Stallman to first. So with all this functionality, all we need to know is a way to handle ArrayList instances dynamically. This is what the condition of an enhanced for loop looks like. For example, for here, string s, and this will be my list here, or y. So yes, actually. So this example, this for loop will step all the items in my list one at a time. At each step, s will hold the current string entry, but we write it for string s here, and string my list here, my string here, and this will be my list. So we can do that another example here. For example, s in my list. We can do, this is the best way to do it. The way that this works for that for loop iterates through each string. I did earlier because I thought I mistaken with Java. In Java we've written write like this. So, but in Kotlin we write more simply. Just we write s in my list. Yeah, and then log.e here, employee. So for example, let's make this employees here, and s, or we can write like this, right? So what's his problem here? Tag okay. Here, so let's hit. So the way that this works is that the for loop iterates through the string, each string in the array list, as you can see here, and assigns the current string entry to s. Then for each in turn, s is used in the log function call. So let's run our loop here and open our logcat window, delete our old logs, and let me show you our blue stacks. Now let's our application is launched. So you will see an output here. As you can see here, output here, Now I can close our emulator, and here you can see you will get output following output. So the for loop, the for loop has output all the names. The reason the Richard Stallman is in between Donald, Jack, and Rasmus Lerdorf is because we inserted him at a specific position. You will see here 1. So which is the second position in the array list, and insert function call does not delete any existing entries but shifts their position instead. There's an incoming flash. Array and array list are polymorphic. So we already know that we can put objects into arrays and array list objects. However, being polymorphic means that they can handle objects of multiple distinct types as long as they have a common parent type, all within the same array or array list. In its simplest form, it means that any subclass can be used as part of the code that uses the superclass. For example, if we have an array of animals, we can put any object that is a subclass of animal and in the animals array, such as cat and dog. This means we can write code that is simpler, easier to understand, and easier to change. For example, also we can write code for the superclass and rely on the fact no matter how many times it's subclassed with certain parameters. The code still works. So now I want to talk about hash maps. Hash maps, Kotlin hash maps, are interesting. They are the type of cousins to ArrayList. So they encapsulate useful data storage techniques that would otherwise be quite technical for us to code successfully ourselves. It's worth looking at hash map before getting back to the later lectures. Suppose that we want to store the data of lots of characters for our role-playing game, and each different character is represented by an object of the character type. We could use some of the Kotlin tools that we already know about, such as arrays or ArrayList. However, with hash maps, we can give a unique key or identifier to each character objects and access any such object using the key or identifier. Any of our character instances can then be accessed with our chosen key or identifier. A good candidate for a key or identifier in the character class scenario is a character's name. Each key or identifier has a corresponding object here. So we simply, in this case of character instance, this is known a key value pair. So we simply give HashMap a key and it gives us the corresponding object. There is no need to worry about which index we stored our characters, such as Geralt, Siri, or trees. Simply pass the name to HashMap and it will do the work for us. So let's take a look at some examples. You don't need to type any of this code, simply get familiar with how it works. So we can declare a new HashMap instance. For example, let's delete our old codes here, and here let's create a val character map here, and map and string and character. Here, and so this code, we done this code implement the character map here. So this code assumes that we have coded a class character. We can then initialize a hash map instance like this. For example, is equals hash map, and we initialized hash map. So when we can then add a new key and its associated objects like this, character map dot path. Here we will give a key chair, for example, Geralt, and character here, as you can see here. Character map character here, and the string here. So actually it's varies or more. Then character map is initialize it to HashMap here. As you can see, we use character map.pub, path, Gerald, and character here, and character map dot path here, theory and character here, and then let's put another character map dot path here, trees here, and character here. We can then retrieve an entry from the HashMap instance like this, val Siri here, and character map get Siri here, as you can see here. So in this lecture, in this section of our course, we looked at how to use simple Kotlin arrays to store substantial amounts of data provided that is of the same type. We also used arrays in previous lectures, which is like an array with a lots of extra features. Furthermore, we discovered that both arrays and ArrayLists are polymorphic, which means that a single array or ArrayList can hold multiple different objects as long as they are derived from the same parent class. We also learned about the HashMap class, which is also the state historic solution, but which allows access in different ways.